All right. So hopefully some of this is a review. We did talk about rational functions the last time, and we did give you guys detailed notes last time, but these are even more detailed. And I put everything that you need to know about rational functions in here. I talked about horizontal asymptotes, that, you know, the horizontal asymptotes, pretty much if x approaches infinity, that is your limit, is whatever the horizontal asymptote is. And I put some rules about horizontal asymptotes. It's the same rules that we mentioned last time. It's the same rules that we mentioned last time. If the degrees, the largest exponent of the denominator is bigger, then you have y equals 0 as a horizontal asymptote. If the degree of the numerator is bigger, then there's no horizontal asymptote. And if the degrees have the same, then it's just the coefficient of the largest exponent divided by the coefficient of the largest exponent of the denominator. So yeah, now let's talk a little bit about exponential functions. And here's what I said we were gonna do. So e to the x, if you guys remember, e to the x looks like this. So because e to the x looks like that, as x approaches negative infinity, I have a horizontal asymptote of 0. So that equals 0. Because you can see as x approaches negative infinity, I'm converging on the y-axis. And I think that's kind of fun there. So this is e to the negative x. So e to the negative x looks like this. See? So as x approaches positive infinity of e to the negative x, I converge on the y-axis again. So I converge to 0. All right, hold on. There's this little light blinking. I don't know why it's blinking, so let me look at it. Okay, I don't know what's going on there. All right, ln of x. So limit of ln of x. Well, ln of x looks like this, guys. I have a vertical asymptote at 0, and I go ever so slowly, increasing left to right, but I'm still increasing forever and ever and ever. It's just the inverse of an exponential function, guys. So limit as x approaches infinity of ln of x is infinity. You can also say does not exist. Does not exist would be an okay answer, but infinity is the better answer here. All right, so I have ln of x, guys. Now think about it. As x approaches infinity, ln of x is still going to be going up. Like it's still going to be increasing the x values or my y values. As my x values get larger, so do my y values, but they're growing really, really slow. So ln of ln grows even slower, but it's still growing. So this one is still, again, infinity. And if you don't believe me, you can type this into a calculator and you should see growth. It's going to be very small growth, but you should see growth. All right, so let's see. Let's see if we understand this now. So I have this limit for letter E as x approaches infinity, and I have 10 e to the negative 0.0001 x. I think I added an extra 0. It's okay, no big deal. They all look the same. So how does this part look as x approaches infinity? Guys, it does not matter. This right here, who cares that there's a 10? I have e to the negative some coefficient x. So that part still looks like this. It's still going to approach 0 as x approaches infinity, just for the 10 e to the negative 0.001. So what does that mean? That means that my end behavior just looks like 1 over 2. So I have a half. Did that make sense to everyone? So I'm going to stop here until I hear everyone say, yeah, that made sense.
Could you re-explain it?
Yes.
Thank
The
you.
graph, if I were to tell you, how does the graph y equals 10 e to the negative 0.001 x look like? That graph looks just like this graph. It looks exactly like that one. The only difference is it's, well, the magnitude is 10, so vertical stretch by a factor of 10. And as x approaches infinity, I'm still converging at 0. Look, it's still going towards the y-axis, towards the x-axis, correction. And as I approach the x-axis, the y value is 0. Does that make sense there, guys? So in essence, what I was going to say,
1 over 2 plus 0?
Yeah, it's like 1 over 2 plus 0.
Okay.
This guy is a 0. Oh man, if someone were to tell you that, that would hurt. You're a 0. Man, don't ever say that, please. Or at least not to me, please. And don't tell your friends that either, because that would hurt me. That would be a sad day. All right, letter F. Check it out. You guys have done this. You just care about end behavior. It's a rational function. And the numerator, 7x squared. And the denominator, x squared. I'm approaching 7. Done. Oh man, I should have made some of these negative infinity. Oh well, that's fine. All right, letter G. Letter G, denominator has a higher degree, so that means that the denominator is growing faster than the numerator. Who cares about this 300 million? I mean, I don't know, I didn't count the zeros there. Who cares about that? As x approaches infinity, the denominator still grows faster than the numerator. So this is 0. Is all this making sense to everyone, guys?
Yes.
Yes.
Yeah, that's what I wanted to hear, guys. All right, next one. Limit of x approaches infinity. I have a rational function. This is an x cubed. That's an x squared. So infinity. I'm growing. As x gets larger, so does my y value. You can also put does not exist. If you don't know what direction you're going, like, oh, I don't know if I'm going up or down. All right, put does not exist. You'll get the credit if it's free response. All right, this one here. My highest degrees are here in the front. They're not always in the front. Sometimes they put them in the back to try to trick you. And so it looks like it's just 7/2. All right, now we get to some funny ones here. So I have, it's the same equation again, J and K, haha, JK. And one is approaching positive infinity, one's approaching negative infinity. So let's see if we trick you guys on this one. So the end behavior. The end behavior of the numerator, as x approaches infinity, that's always gonna be 5 times some positive number. In the bottom, because it's being x squared divided by square root, it's always just gonna be x, because it's a square root of x squared. So this one approaches positive 5. All right, let's talk about letter K. Letter K. You don't care about that minus 24. You care about your end behavior. In the bottom, the square root of x squared is x. The denominator is always positive. Why is it always positive? Because I'm squaring it first and then take a square root. The numerator, because I'm talking about negative x values, is going to be always negative. Because I have a negative in there, negative divided by positive, this end behavior is negative 5. The most horizontal asymptotes that a function can have is 2 of them. And there it is. Usually, logistic curves have 2 all the time. We should have covered that in Precalc, but because of the pandemic, I'm going to blame that on the pandemic. But we'll get to it eventually, I hope. Did
I have
that
a
make sense,
question.
guys? Okay, what's up?
Sorry. Why is the numerator always negative again?
Because the x values are negative. It says x approaches negative infinity.
Oh, I see, and it's being multiplied by it.
Yeah, it's 5 times some negative number. Did that make sense?
But that's only when x is approaching negative infinity, right?
Correct.
Okay.
Only when x is approaching negative infinity. If it were approaching positive infinity, then we would just say 5 times some positive number. Are we okay there, guys?
Yes.
All right, here we go. This one's not hard. At least I hope it's not. I'm approaching negative infinity. End behavior, I'm going to circle what I want. Circle. So end behavior on the bottom is x. End behavior on the top is square root of 8x squared. Well, let's see. Square root of x squared. Oh, by the way, the bottom is negative. How come you guys didn't tell me? Tisk, tisk. Why is the bottom negative? Because x is approaching what?
Negative infinity.
Yeah, right off the bat, cancel C and D. Positive divided by a negative is a negative. All right, next. You can actually already cancel A. So man, this is a bad problem because you can get lucky on this one. Darn it, we all know it's letter B. But let's do it the right way. The square root of x squared is x. And now I got to worry about taking the square root of 8. So obviously it's going to be negative because those x's cancel out. And the square root of 8 is the same thing as, 4 times 2. So negative 2 square root of 2 because the square root of 4 is 2. Yeah, I'm not going to put this question in there, number 4, because that one you can get lucky. I still want to see the work though. If you get a number divided by 0, it's a vertical asymptote right off the bat. I guess I should put that in there somewhere. Number divided by 0 is a VA. Which one's the one that has the limit? If it's 0 over 0. And by the way, this is actually not even like math language. These are like shortcuts. I'm not trying to teach you guys shortcuts. So don't ever write that on an AP exam or anything like that. Some number divided by 0 is a vertical asymptote. Those are shortcuts for you. All right. Notice that the limit does not exist. It's not an answer choice. So they want the behavior. Oh my God, Chavez, I don't know how to do this without a calculator. Yes, you do. Yes, you do. We know that ln of 1 is 0. At least I hope we know. I really hope we know that. ln of 1 is 0. And I'm approaching from the right-hand side. I'm approaching from the left-hand side of 1. So here's how ln looks like, guys. So look, think about it. Here's 1. I'm approaching from the left-hand side. So that means I'm talking about really, 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 really small negative numbers. See, do you guys see that? So what do I have? Really, I have like this. I have like a number 1 or really close to 1, 0.9, 0.99, 0.99999. So a number close to 1 in the numerator. But in the bottom, I have a really, really small negative number. When I mean by really small, I mean magnitude, because small is like more to the left, but we're talking about magnitude. A really, really small negative number. So 1 divided by a really, really small negative number is going to give us negative infinity. And in case you're wondering, Chavez, I have no idea. This is hard. Guys, look. 1 divided by negative 1 is negative 1. 1 divided by negative 0.1 is negative 10. 1 divided by negative 0.01 is negative 100. 1 divided by negative 0.001 is negative 1,000. It's just going toward negative infinity, guys. I should have put that negative in the bottom, but you guys know what I mean. Cool or not cool?
I'm confused.
Okay, what's up?
I mean, I get like what you were saying, 1 divided by a small negative number, but like from that graph, you wouldn't get negative infinity. So that's why I'm kind of confused.
No, well, this is the ln graph. This is just y equals ln x. And as x approaches 1 from the left-hand side, I'm getting smaller and smaller numbers. So if I were to choose 0.9 as the next value, you probably get negative. I'm just making this up. I don't know what ln of 0.9 is. I probably get negative 0.1. If I choose 0.99, I probably get negative 0.01. See? So as I get closer and closer to 1 on the x value, so the numerator is just going to be 1, like 1, but the bottom is going to get smaller and smaller in a negative number. Negative 0.1, negative 0.01, negative 0.001, negative 0.001. And so 1 divided by a negative 0.0001 is negative infinity. Did that make sense or no, Tiff?
Yes. I think I also need to visualize it. So I know you don't want us using calculators because that's like cheating, but I wanted to see like what it would actually look like.
Yeah.
So,
Maybe we can hold on in a little bit. It's because I want to get through this lesson, but maybe stick around and we can talk about like, all right, let's type it into the calculator. So we put this in Desmos, and you can see a table. You can type in 0.9 and 0.99 and 0.999 and 0.99999, and the y values are going to get larger and larger in the negative direction. You know what I mean?
yes.
Okay. So stick around and we can mess around with those graphs. All right, guys. Look at question 6 here. We already know if you plug in the number 2, you get a number divided by 0, so it's a vertical asymptote. But I want to know whether it's positive or negative. So you can already delete B and C. So I'm going to factor out a 2 in the bottom. So let's see. 5x plus 1 over 2, and then x minus 2. All right, so think about it. You're approaching 2 from the left-hand side. So that's like 1.9, 1.99, 1.9999, 1.9999999. Sorry, I'm having too much fun there. The numerator is always going to be positive. Chavez, why? Because you're doing 5 times 1.9 plus 1. Since you're doing 5 times a positive number and then you're just adding 1 to it, it's always going to be positive. So the numerator is always positive. In case you're wondering what I'm doing, guys, I'm trying to figure out whether it's positive or negative. Now the denominator, I'm talking about numbers smaller than 2 because I'm approaching from the left. 1.9 minus 2, is that going to be a positive or a negative number?
Negative.
Yeah, negative. What's positive divided by negative?
Negative.
Negative. And there it is. That's my answer, guys. These are the hard ones. These, yes, we're giving you hard ones, guys, because we want to make sure that we're pushing you to the limits. I'm probably going to have to redo a video, guys, because these jokes are way too lame. And if we have all these outsiders watching my YouTube channel, they're going to be like, man, what are these guys doing? His jokes are so lame. So I'm going to have to redo it again. Plus, look at all this. Do you think outsiders will understand all this? All right. It gets back to easy. Well, I don't know. I think it gets back to easy. Before we continue, let's write what we know. Because we're obviously going to need trig stuff, right? So let's see. We know cosine squared plus sine squared equals 1. We know, let's see, we divide everything by cosine squared. 1 plus tan squared equals 1 over cosine, that's secant squared. And then we know if I divide everything by sine squared, cosine over sine, that's cotangent. So cotangent squared plus 1 equals 1 over cosine. What did I say? I divided everything by sine? Sine. Cosecant squared. Okay, so we know those three. And then we need to know one other thing. What else do we need to know? We need to know our limits, our limit rules. So there's 3 of them. Well, there's really 2 of them. Here's one of them. We need to know limit as x approaches 0 of sine x over x equals 1. We need to know limit as x approaches 0 of cosine x minus 1 over x equals 0. And you can also toggle this one around, not toggle, but rearrange the numerator. You can say limit as x approaches 0 of 1 minus cosine x over x equals 0. And those were our special limits that were on that page from limits 2, if you guys remember. Cool or not cool?
Cool.
Okay. By the way, guys, real quick, don't worry, I'm going to edit this piece out. Should I leave the video as is and just upload it anyways, or should I just make a new one?
Just leave it. It's good.
Just leave it? Okay. Thank you,
Yeah,
guys.
just-
You guys are the best. All right. Here we go. This is just like before, guys. 1 minus secant squared of 6x over 2x squared. I want to rewrite this limit, or I want to rewrite this in the inside specifically in terms of sine x, because that's all we know. That's all we know. Or actually, you know what? Let's put the tan one in here. We said limit as x approaches 0 of tan x over x equals 1. So there we go. Those are the 4 limits that we know. So let's rewrite the 1 minus secant squared. I'm going to use this one right here. 1 minus secant squared is equal to negative tan squared. So I'm going to write limit as x approaches 0, because I haven't figured it out yet, equals negative tan squared of 6x over, and instead of writing 2x, you know what? We can leave it as, no, let's write 4x squared. Okay, now I'm ready to expand. I'm using this one right here. So I'm going to write the word limit because I haven't evaluated it yet as x approaches 0. I'm going to write a giant parenthesis because I'm going to expand. So I'm going to write negative tan of 6x over something. We're going to figure out that something in a little bit. Tan of 6x over something. We're going to figure that out in a little bit. And then I'm going to move the 4 here. I'm going to put 1x there, and a 1 at the top. So there it is. I have not done anything, or I guess I should close a parenthesis. Close it. All right, now I'm going to balance it. So here we go. What do I need in the bottom of this one right here, the first one? What do I need right there, guys?
A 6?
Yeah, put a 6 down there, put a 6 up here. I guess it helps if I put like happy face x over happy face. There we go, that's better. Come on, buddy. happy face X over happy face X. Okay, same thing on this one. I put a 6 on the top. And there we go. It's balanced. It's nice and pretty. So I'm going to put equals. I no longer have to put the word limit because I'm just going to tell you, I'm just going to derive this. I'm just going to answer it now. This expression here is just -1 times, this expression here is just 1 times, let's see, what's that? 36 over 4, which is it a -9? I see -9. And that's it, guys. Are we okay?
Yes.
Okay. Look at question 8. Question 8 says limit as x approaches 0 of 3 over 4x cosecant 3x. Chavez, I don't know any of this. Relax, guys. We have our little formulas. We're going to use this one. We're going to use that one. Cosecant is the reciprocal of sine. In case you don't know that, side note, this is why pre-cal is important, guys. So cosecant x is the reciprocal of sine x, which means I can rewrite it like this as well. See? So cosecant's in the bottom. I'm going to rewrite it. I'm going to go back to red. I'm going to go limit as x approaches 0. Leave the 3 in the numerator. Let's see. I'm going to leave the 4x down here. And I'm going to put the sine of 3x up there like so. So there it is. All I did was this, guys. All I did was that. Okay, now let's expand it. So I'm going to write limit as x approaches 0. And I'm going to parenthesis. I'm going to put 3/4 by itself times. I'm going to write sine 3x over x times. Oh no, I have that 3/4 that I can use it to balance. Okay. So I need some number right there next to that x. What number do I need?
3.
3. If I put a 3 in the bottom, I put a 3 in the top. There it is. So 3 times 3 is 9. So I have 9 over 4 times 1. So 9 over 4. See?
I like these better than the other ones.
Yeah, because they're like chemistry. You're just balancing. All right, let's see. Ooh, look at this one. Chavez, I don't know what to do on this one. I see a 1 minus cosine, but I see an x squared. I don't see any limits with x squared and 1 minus anything. You're right. So turn it into something that we do know. So turn it into sine squared. So we're gonna multiply by the conjugate. We're gonna multiply by 1 plus cosine 2x over 1 plus cosine 2x. When we do that, we're gonna have, you're gonna continue to write the word limit. Limit as x approaches 0, so that's the number 1 mistake. Some of you guys don't write that word there. And 5x squared, don't bother distributing this. 1 plus cosine 2x, close. In the bottom, you have the difference of squares, so that turns to 1 minus cosine squared of 2x. So now, from your side note, from this one right here, cosine squared plus sine squared equals 1. So then that means 1 minus cosine squared has to equal sine squared. Yay. So look, now we're going to write limit as x approaches 0. And I have 5x squared. Chavez, how come you're not putting that giant parenthesis? I will in a little bit. I don't need it yet. Sine squared, and I got to keep the argument 2x. All right, now I'm ready. Now I'm ready to expand. I write the word limit because I still haven't solved anything. I put a giant parenthesis. And let's see, what do I want to do first? Okay, I'm going to go ahead and take care of that x squared with the sine of 2x. X over sine 2x times x over sine 2x. So there we go. We already took care of the x squared and sine 2x. So what have I not taken care of? I have not taken care of the 5 times 1 plus cosine 2x over 1. And there it is. So that's supposed to be equivalent. Those are the same. I'll wait for you guys to catch up. Let me take a sip of my coffee. Okay, here we go, guys. Here we go. This is 1. Oh, nope, that's not 1 yet. I have not balanced it out. How come you guys didn't tell me? I was here thinking that we were done. All right, what do I need right there?
A 2.
A 2. If I put a 2 in the top, I got to put a 2 in the bottom. What do I need right there?
A 2.
Another 2. So put a 2 in the bottom. And now I'm good. So here we go. So here's what we have. We have 1 times, let's see, cosine of 0 is 1. So I have 5 times 2 over 4. So what do I really have? 5/2. You're done, guys. Wasn't that cool? Oh, look at number 10. Oh, number 10's a cool one. I like it. I like it. All right. Número 10. I'm going to learn French, so I can say the number 10 in French as well. This one, can I do direct substitution? What do you guys think? Someone say yes.
Yes.
Yeah. Let me tell you why we can do direct substitution since I hooked you up with guys with the answer. You don't get a 0 in the denominator, guys. So because you don't get a 0 in the denominator, you can just do direct substitution. So here comes your precalc again. Cosine of 9 pi over 4, which we should know. Everyone here should know that answer right there. Times 6 times 9 pi over 4. In case you forgot, 9 pi over 4 is just barely above 2 pi, because 8 pi over 4 is 2 pi. So that means 9 pi over 4 is a whole revolution and another pi over 4. So there it is. That's 9 pi over 4. So at pi over 4, the x value is square root of 2 over 2, and the y value is square root of 2 over 2. So now that you know that, notice that I didn't write the word limit. And I didn't write the word limit because you already see that I put a 9 pi over 4 on the inside. So now that you know that, square root of 2 over 2 minus 1, we're probably going to have to do common denominator there. And then I would probably reduce this. Let's see, 2 and 3, and then 3 times 9 is 27. 27 pi over 2. Oh, you know what? Even better. I'm going to turn that 1 into 2 over 2, and then just go ahead and then just cancel the 2's in the bottom. 2 over 2, and you have this square root of 2 minus 2. You know what? I'm not going to go too fast because every time I do that, I lose you guys. So I'm just going to slow down. You can already see what's going to happen, though. I hope. You can actually leave it like that, and that would actually be the correct answer on the AP exam. But let's simplify it, guys. Square root of 2 minus 2 over 2 times 2 over 27 pi. These 2's cancel out. Square root of 2 minus 2 over 27 pi. There's my answer. Are we still okay, guys?
Yes.
Okay. All right, question 11. Before we do number 11, how do we feel? Can we take some more?
Yes.
Okay. Well, that's Godinez. What about everyone else? I need to hear you guys. Unmute yourself and say, yeah, we can do more. Okay, but someone say, yeah, we can do more. Like, yes, get pumped. Not everyone at the same time.
Yeah.
Okay, thank you. Let's do this, guys. It says, given f of x is 5 cosine x and c equals pi over 6, determine whether the limit as h approaches 0 of f of c plus h minus f of c over h exists, and give value if the limit does exist. Okay, so let's see what f of pi over 6 is first. So let's do this a step at a time. So f of pi over 6 equals, let's see, 5 times cosine of pi over 6. So here's your precalc. Cosine of pi over 6, so 5 times square root of 3 over 2, and maybe you want to write it as 5 square root of 3 over 2 like that. Okay, I don't see anything crazy right now. Let's see, now let's do f of pi over 6 plus h. All I'm doing is this. I just did that right there where c is pi over 6, and now I'm just plugging in what c is. 5 cosine pi over 6 plus h. Now, is there a way for me to expand that? Yes, from Precalc. See, guys, Precalc doesn't go away. Cosine, when you have two arguments that are being added, a plus b, hopefully you remember that this is cosine A, cosine B, minus sine A, sine B. So now that we know that that's what it means, I'm going to come back here and I'm going to expand what is in brackets there. So here's that 5, and here I am expanding what's in brackets. Cosine pi over 6 cosine h, and you can put a parenthesis on the h, I'm not going to, minus sine pi over 6 sine h. I'm going to distribute the 5. So it's okay. Hey, look, notice I'm just putting an equal sign, so that means I'm continuing this one. So make sure, you know, once we stop, we'll stop and we'll evaluate it. So we have 5 square root of 3 over 2 cosine h minus, and then sine of pi over 6 is a half, but I have a 5 over here that I got to distribute it with. So 5 half sine h. Okay, so now here's what I'm going to do. Now I'm going to do limit as h approaches 0 of f of pi over 6 plus h minus f of pi over 6 all over h. So I'll wait for you guys to catch up. I'm going to write my expression. F of pi over 6 plus h is this one right here. So I'm going to write the word limit as h approaches 0 of 5 square root of 3 over 2 cosine h minus 5 half sine h. That's what's f of pi over 6 plus h minus 5 square root of 3 over 2, and all this is over h. So catch up right there. Ooh, are we going to have enough space? Yeah, I think we do. All right, here we go. Limit as h approaches 0. I'm just going to reword it, guys. I'm going to move this here, and I'm going to move that there. And because there's no equal sign, I have to keep the sign. So I'm going to write it as 5 square root of 3 over 2 cosine h minus 5 square root of 3, that's a 3, over 2 minus 5 over 2 sine h all over h. Now, okay, catch up to there, and I will tell you why I did what I did. I did that right there because I want to force myself to use these equations right here. Travis, what equation are you talking about? I'm talking about this equation right there. I want to force myself to use, and I'm going to use this one as well, plus the properties that we learned a little while ago. Well, that we learned last time. So here we go. I can separate this because this is all just all that. I can separate this into two limits using my properties. I can do these two, and then I can do that one. It's all divided by h, so it's the same thing as 1 term divided by h, 1 term divided by h. So I'm going to take these two terms here, and I'm going to factor out a 5 square root of 3 over 2. So let's see. Let me see if I can do that. Limit, and then a little bit we'll clean it up. As h approaches 0. So here we go. I'll clean it up in a little bit. 5 square root of 3 over 2, parenthesis, cosine h minus 1, close it, all over h, minus, and then I still have this part here. Darn it. Oh yeah, I have room. Minus, let me make the minus over here. Minus limit as h approaches 0 of 5 half sine h over h. So catch up to there, guys. And then this is just a constant. And I can write that in front of the word limit, remember? Just like we did with our properties. So here we go. I'm going to write 5 square root of 3 over 2 limit as h approaches 0 of cosine h minus 1 over h minus 5/2 limit as h approaches 0 of sine h over h. And I'll wait for you guys to catch up. All right, finally. So now let's just simplify what each one is. So I have 5 square root of 3 over 2. That's this part. And then this that I'm circling in blue, that's just a property. So let's see, let's look up what that is. Cosine h minus 1 over h as h approaches 0. That is cosine x minus 1 over x. Just replace the x with an h. That is 0. So that times 0 minus 5/2. And then this everyone should know, I hope. What is sine h over h? Limit as h approaches 0 of sine h over h.
1.
1. So my final answer, negative 5/2. If we show that to the junior high, will they get scared? Nah, they won't get scared. They're math life. They love this.
Wait, to clarify, what would it look like if the limit didn't exist?
We wouldn't have an answer. If the limit didn't exist, we would have like some number divided by 0 or something, or maybe it wouldn't converge on something. But these limits are always going. If you see a trig function like 5 cosine x, it's always going to exist. Don't worry, you'll be able to do this question in like 3 seconds in about 2 weeks. Right now, we're going to have to do it the long way, which is this route. You actually found what the derivative of 5 cosine x is at pi over 6. The derivative of 5 cosine is negative 5 sine. You plug in a pi over 6 into sine. Sine of pi over 6 is a half, negative 5/2. And in about 2 weeks, you'll be able to do that in 3 seconds. But right now, we're not there yet. Cool or not cool, guys? I know that this is tough, and I know we're probably reaching maximum. By now, you're probably like, man, I don't know if I can take another question. It's the last one, guys, and this will be it. We won't do any more after this. You guys ready? All right, this one's coming from UH. This is not on the AP exam. Chavez, why are we learning something that's not on the AP exam? Because there's still professors that want you to know the epsilon delta definition of a limit. This is called an epsilon. It's a lower limit. It's a lowercase epsilon. And this is called a delta. It's a lowercase delta. Lowercase and lowercase. It says for the following limit, find the largest delta that works for epsilon 0.01. So this is like error, essentially. So what they're pretty much saying in English, this is what they're saying in English, guys. It's saying, how close must x be to 2 so that, because x is approaching 2, see? So that x over 3 is within 0.01. Oh, what happened there? Of 2/3. That's what it's saying, guys. How close must x be to 2 so that x over 3 is within 0.01 of 2/3? So relax. It's actually a very simple question. It's just that certain teachers don't teach it, so that's why they think it's hard. Because that's why students think it's hard, because the teachers don't teach it, and then you read a textbook, and when you read the textbook, it's not made this simple. So look, this is all it is, guys. This is all it is. How close must x be to x be to 2 so that x over 3 is within 0.01 or 2/3? X over 3 is your function. So whatever f of x you have in there, that's what you're going to write in here. And since they want it to be within 0.01 or 2/3, so here's what you're going to say. So to get the difference, that's easy to do. To get the difference, x over 3 minus 2/3. See, that's the difference. And I want it to be no greater than 0.01. So that error must be smaller than 0.01. And there it is. That's all there is to it, guys. That really is. So then we just solve. X minus 2 over 3 less than or equal to 0.01 times 3, x minus 2 is 0.01 times 3 is 0.03. You can stop here, but I'm going to keep going one more step. If they wanted the x values, they don't. They want to know the tolerance of it. So there it is. The tolerance is 0.03. But if they wanted the x values, let's see, plus 2, so x is within 2.03. That's a simple one there. And then what's 0.03 minus 2? Is it 1.97? So x values, if they wanted the x values, x has to be between 1.97 and 2.03 to be within 0.01 of 2/3. That's what it means. Stop here. That 0.03 is the answer. And that's 0.01. Letter B. Whew, we did a lot today, guys. Let's come back.